Yeah, if you would like to contribute to the notes on the session, we're taking notes and you taking them in Etherpad. So if you guys. All right, I think this session is time to start. So welcome to EMU. You've probably all seen the note multiple times, but since it's Monday, you probably haven't seen it before, take a quick look. So we have started a GitHub section so that we can work on our drafts there, and I think several of the drafts are already up there. So let us know what you think of this. We've used this in TLS extensively, and I know a number of other groups have used it a lot to help track issues and the status of the document. So emu-wg is what you're looking for on GitHub. Okay, for the agenda, I think blue sheets, we should send those around. And then we'll talk about EEP-TLS, and then EEP-AKA, and then a couple of the items that are newer items that aren't quite on the charter yet. So anything anybody else had? Any agenda bashing that needs to be done? So we have two working group drafts right now, and they're different kind of drafts than, I guess there's an emu beer in Australia, so, or I think it's Australia. But the drafts we're working on are different. We have the EEP-TLS 123 and the EMU, the EEP-AKA BIS. So those are the current working group items. I think we'll have a couple more that we'll be bringing into the working group soon, and hopefully we can start getting these towards completion as well. So I think this will be a good meeting. I think there's significant work done on both of these areas. So, and I think now we go to, are we up with, which is the, yeah. Uh-oh. Is this where we want to start? Are you good, John?
I think so.
Okay. I think you may need to let us know when you want to change slides. I don't know if you can do it remotely.
I'll let you know. So you're presenting there. Yeah. Now I see. Great. So this is version 2 of the IETF 103 draft. The version that was presented at the last meeting was 00. So we have seen 2 updates of these drafts. And basically the discussions and conclusions last time was most of the things we discussed at the last meeting, we decided not to change. But there were 2 things that we decided to change, and that has been done. So one of the changes are quite straightforward. The session ID now starts with 0D, as suggested by Bernard Abuba. The other discussion resulted in a comment from and suggestion by Jim Schad to add an empty TLS record to the protocol when to lower the uncertainty from the EEP peer. I will go into the details of this. But this has been done, and there's a new section in the document called EAP state machines that discusses this. And then there are some editorial changes. And this was the changes to between the 00 and 01 version. Then the changes between the 01 and the 02 version are only in the privacy considerations and considerations for pervasive monitoring, as well as some additional editorial changes. Yeah. So the first change is, as I said, quite straightforward. EPTLS should start with 0D hex value, and this was missing from 00 as pointed out by Manard. So this is now updated. Instead of deriving the session ID directly from the TLS exporter, a value called method ID is derived, and this is according to some other EAP RFC, I don't remember which. And then the session ID is created by concatenating 0D with the method ID. And this makes the session ID 65 bytes long, as in RFC 5216. Yeah. Next slide, unless there's any comments. Other change that may require some more discussion is the empty TLS record. And this was the discussion was brought up by Juni when he implemented this maybe not the 00 version, but the version even before. And he said that with a new session ticket, it's hard for the client to know what will come next, and it messes up the EAP state machine a little bit. Then there was a comment from Banan that this should be made cryptographically secure, and Jim Shad suggested added an empty TLS record, which seems like a good idea. So the mechanism implemented in 01 and 02 is that the EAP server commits to not send any handshake messages. And handshake messages include post-handshake messages, including then new session ticket. And it does that by sending an empty TLS record. Don't know if we should go through the pictures first. Let's see, empty TLS record. This is just an empty application data record layer with length where the plain text length is 0. And after doing this, the server does not send any more handshake messages. But it's still 3 possible options what it might send after this. It's EAP success, failure, or a TLS alert message. And as I will show you pictures of all of this, but yeah. So first, here's the case when we have success. To the left, we have the ordinary successful mutual authentication. And as you can see here, marked with a green rectangle, we have a new field here, a TLS empty record. And by sending this, the server commits to not sending any more handshake messages. And here, in the case of a successful client authentication, the server responds with EAP success. On the right side, we see a mutual authentication, successful mutual authentication, where the server sends a new session ticket to enable resumption in the future. And in this case, the server does not send the empty record after it's finished, because it will send a post handshake. So it sends an empty record after the new session ticket. And then in this case, everything is successful. Next picture. Here is the message diagrams when you have a failure. In the left page here, there is no empty record because we never reached that state. The server reacts the client hello. In the right side, we have this case where the server authentication fails or the client rejects it for some reason. And then, and this is the case without the new session ticket. Then the server sends TLS empty record, and afterwards there will be a EAP failure. And then next slide, we will have the most complicated case. So here is, on the left side here is the successful mutual authentication as described earlier. The server commits to not sending any more handshake messages, and if everything is okay, it will send EAP success. Here, but on the other hand, if everything is not okay here, so the server rejects the client authentication, then the server responds with a EAP request with a TLS alert message. So the commit here with the empty record is to not send handshake messages. And this is, I think, the best we can do. At least this is, as far as I can understand, aligning with RFC 5216, in which this case is what happened if the client authentication fails during a resumption. Then you have the same scenario. This server sends either success or it sends an TLS alert message. Yeah, no comments. Then sitting. So the next slide is potential updates to this. One thing was that when writing this presentation, I noticed that we have error cases for, we have figures illustrating the message flows for basically every error cases. And this was requested on the mailing list to add more error cases. And I saw now that we don't have an error cases for the EAP TLS client reacting the new session ticket. I assume the client would send a TLS alert message in that case. Do we want such a figure? Then that could be added to the next version. Then further update a couple of, we have had discussion about privacy. The EAP peer may reveal its identity in two different ways. It's firstly, it can send its identity in clear text in the first EAP response called my ID, I think, or my identity in the draft. And this is for all TLS version. And the second way the EAP peer may reveal its identity is to send its certificate in clear text. And this only happens in previous versions of TLS. And what we can do in the privacy, for privacy, is a little bit restricted with what kind of legacy interop a deployment wants. But one thought I had was that, can we do something more specific about the identity sent in the first message? Can we recommend or mandate that the peer sends a confidential identity, for example, anonymous NI? Or is there EAP servers that will not like this? RFC 5216 doesn't say very much about this. It says that servers that does not support privacy may go to failure when the client sends an empty certificate list, but it doesn't say anything about identities as far as I see. Yeah, question from Jim.
Jim Schott. In point of fact, actually, radix essentially says you do send just at your domain and in the first EAP message, and they use EAP TLS in a lot of places. So that is standard behavior. There's no problems with that.
Yeah. So can we have must do
Yes.
that? Yeah, good. It's good. See, the third future potential update that I had been considering when writing now the updated privacy section is that should the draft give any guidance since RFC 5216 was published, several attacks on TLS, earlier versions of TLS have been published, which is one of the reasons why TLS 103 was developed and published. But in fact, most of these attacks do not really apply to EAP TLS, as EAP TLS only do a handshake and does not protect application data for a long period of time. But some of the attacks probably do, even if I have not remembering the details. Should the draft give guidance or references how an implementation should mitigate attacks on early version of TLS?
So speaking as an individual, right now, and this is Joe Salloway, I think certainly we shouldn't really talk about things that aren't actionable to somebody who's implementing it for things that don't apply. I don't think we should include. I'm also a little bit reluctant to include things relevant to earlier versions in this particular update. But I'd like to hear other people. So, Jari.
Jarkko, and I agree with your advice. What I came up to say here, though, is that I struggled a little bit with the similar issue in the AKA draft, like how much of the AKA attacks should I describe? And one of the crucial things I think determines this is if there is a reasonable reference for those other things. And I assume in the case of TLS, there is that TLS working group documents, perhaps the TLS 113 document actually describes some of those old attacks. So you have a good reference to point to, and then you could just handle the things that actually apply to your protocol.
So I just have a question. This is Elliot Lear. The question is, if there are attacks against TLS 1.3 in particular that would not be mitigated by the advice given in security considerations for 1.3 and are in any way specific to EAP, for instance, then I think those have to be described here in some detail. I don't know.
So it doesn't seem that we should have a long section on it. I don't think there are any attacks on TLS 1.3. I think there is a document in using TLS in application describing attacks. Should we just refer to that or not even referring to that?
If this is Elliot again, if you think the attacks are applicable, then you certainly should refer to them. You don't have to redescribe it, but adding maybe at least my advice would be to just add a reference, but not to spend a lot of effort recapitulating something that went through the whole process of an RFC to produce.
Yeah, it's also not clear to me that we we want to go too much into what the problems are with the old versions and how you may or may not be able to protect against them. I'm a little bit torn because that could be useful information for some implementations, but really if they're reading this document, I think they're more looking to implement the new thing. But if at the same time they could mitigate old things, that would be good. So
I add a short reference then to that draft.
So just this is Elliot again. One thing you can do is you can put actually something in the front matter of this document, which says this is the attacks are actually motivation for this work, right? At least in part. Some of the holes in the earlier versions of TLS are motivations, and I think you've done some of that, right? But just maybe you could even add a reference up front against that. You know, you don't have to go into any detail. I really wouldn't, right? That anytime we muck up these specifications with a lot of, you know, motivational material, if it gets too motivational, people are like, okay, get on with it. What's the spec? Right? But a line is not too much.
Yeah. Good.
So maybe the appropriate thing to do would be to figure out what is applicable, or you know what attacks are applicable, and if there's anything that we could put in the document, and see if that's something that would make sense. It's not clear to me that there's going to be a whole lot.
Okay, so sorry.
Yeah.
This is Elliot again. So one of the reasons I'm sorry for speaking so many times with the microphone. One of the nice things about doing a little bit of that is that some of the attacks that we've seen on earlier versions of TLS are like browser specific, or you know very much focused on that particular use of TLS, and so calling out the non-browser risks, you know, a line or two in the non-browser risks maybe might be useful. And the reason that I say that is that what we've seen, and maybe this is a good thing, but we've seen basically a blanket, you know, attempt to just get to the latest version of TLS without actual analysis of what the attacks are, and that poses a long-term threat in terms of people having spent money on upgrades that they didn't need, and they say, "Oh, you're just the boy who cried wolf again." See, having actually specific justification does help on that point.
I could send an email to the use of TLS in application list and the TLS working group and see if asking for advice what of the attacks would specifically apply to EAP TLS when you only use the handshake. These working groups have the expert in these areas, and there are people that probably have these details in their heads. Let's see if we get any advice.
I mean, that's probably a good approach. I think that there may still be the people in those groups won't know exactly how EAP uses it and those particular use cases, so they may not. They may or may not. You may or may not get good feedback from that.
Yeah, I add a reference, and then we'll see what feedback I get from the discussion. But we keep it short and very only things really applicable to EAP TLS. Not spending too much time on that. Yeah, I think let's turn in more questions. Next slide. So this was quite short. I take that as people like the changes if they have read them. I think what this draft needs now is more reviews and more feedback, also more implementations and possibly interop. I don't know. What's the chair's views? How do we move forward? Could we get somebody to commit to review this, or?
How many folks in the room have read the draft? Okay. Yeah, we would, in order to kind of move forward on some of these, we need some more reviewers. Is there folks in here who could commit to doing a review? Jim Shad, anybody else? What's your name, please? Chuck. Okay. Make sure we get that in the notes. Daniel, you want to review as well? Yeah, so I think we can get some more reviews. Do we have, how many implementations do we know of? Any?
Uni had implemented this at least,
Okay.
an earlier version.
So we'll need to find some more implementers to have an interop. So I think if we can get a few more reviews and kind of finalize these last open issues, which just seem pretty minor, we may be able to start working towards a working group last call on this.
Seems good.
Yeah, I think that's all right. All right, and the next is large certificates.
Yeah. Great. So this presentation will hopefully be very short. So we made an update based on the discussion at the last IETF. You can go to the next slide. So it has been updated from 00 to 01, and there's not that much added information. It's the draft has been reorganized to distinguish between recommendation requiring change of certificates and recommendation only requiring changing the code. For example, updating to TLS 1.3. So there's some new text describing the cached information extension that was discussed at the last time, stating that it in some cases is not helpful if the handshake fails anyway, but it can be helpful if you have done an authentication in your home network and then you're roaming and a full handshake without this would fail. This can make it possible to do a handshake there, authentication. Then there is a new text stating that TLS can significantly reduce the number of messages exchanged. There's a new section placeholder for guidelines for certificates, more going into the details of different fields and things you should do in the certificates. And then there are some editorial changes. Can go to the next slide. So the new document structure is basically to split up section 4 into 3 different subsections, where 4.1 looks at things updating certificates, 4.2 looks at recommendation and guidelines updating code, and 4.3 have guidelines for certificates. And here we are waiting for input. Sean Turner promised to write something eventually here, which we might hopefully have to the next IETF meeting. Something like that.
What sort of things were going to go in the guidelines section?
So Mohit, no hat. So Sean Turner had some ideas on how you can give guidelines to people issuing certificates, like don't put tons of OIDs into the certificate, don't have like thousands of subject alt names in the certificate. So those kind of guidelines, especially so using TLS on the web is a little bit different from using TLS on EAP, where you have access points that drop sessions if they don't complete in time.
Okay. We can try to find Sean and poke him. Yeah. All right.
Yeah. Next slide. So that's it. Except that planned update from Sean. I don't think we have very many else planned updates. We will need suggestions and reviews and feedback from the working group. And both this and the EAP TLS 1.3 draft is on GitHub. So if you want to know what we are planning for the next version and any open issues, you should look there, and feel free to commit issues there or make a pull request or comment.
Okay. Any additional questions or comments on this? We'll need reviewers for this as well. But I think we focus on the TLS 1.3, getting those reviews done, and if we get that moving, we'll be able to get this moving too, I think. All right. Anything else with respect to EAP TLS? All right. Thank you, John. And I think we'll move to EAP, AKA. Yari, you're up. Let's see. Here's a. Let me just get this centered for you.
Okay, so I'm just going to go through the draft and some of the issues there, and if you're in the room and don't know what this is about, this is basically some old or 10 plus years old technology that has been very widely implemented, but is now finding also use in the upcoming 5G standards. And as part of that, we're trying to make sure that everything's correct, and things that we've learned in the past or things that we missed on the first specifications are actually corrected. And the initial thought was that there's three things that we need to do. Identifiers are a little special in 5G, so I figured we need to do something for that. The EAP aka prime does sort of like a network name binding that you or both parties agree to what they're authenticating for, what network they're connecting to, and that changes a little bit also for 5G. So fix that. And then we knew that exported parameters were forgotten in the old RFCs, that we didn't do that, even though some other RFC required that. So fix those three things. But it turned out that we actually needed to do a bunch of other stuff too. In the meantime, the sort of the IETF demands for what should you talk about in the security consideration section have increased, like talk about privacy more, talk about pervasive monitoring considerations. Of course, we learned something about vulnerabilities in the meantime, so document those better. Also, we got some comments actually from John relating to pseudonyms and fast re-authentication identifiers and how their spec on the previous version was a little bit weak. Didn't specify how to do that securely or didn't set the requirements right. So we did that and updated some references. There's been two updates since last IETF 02 and 03. The general status is that we now believe that this, well, I know I said this before, but now we really believe that this is in sync with 3GPP specs. We've done some 5G related updates. We've done some general updates, and we've done a lot of work with the security considerations section. I'm going to go through some of the main points here. So first of all, identifiers. This was kind of clear previously. Use the name that was sent in this protocol. And it's important to get this right, because the identifiers are not just like things to point to the right record, but it's actually also used as bits inside the key derivation. So So if you get it wrong, it's going to fail miserably. But in 5G, there's a couple of additional considerations. First of all, the EAP session is inside the 5G native attachment procedure, and you don't actually need the EAP identity request and response. It will be sort of an extra round trip for no good reason. Have to take that out into account. There's also two different identifiers. One is the permanent identifier called the SUPI, and then there's a concealed or privacy friendly identifier called the SUKI or SUSI. And the idea is that these are used for different purposes. The permanent one we can use for key generation, or that's what they wanted at 3GPP. So that's what we'll do. And then obviously the privacy friendly one is the one that we should use for any other passing of identifiers around. And there's a couple of things in the draft. First of all, or there's additional text to fix this case where, like the previous RFC said, that always ask or should ask, I think was the phrasing for identifiers inside the EAP AK method rather than in the EAP framework. But in a case where you are connecting to a 5G network and using the 5G protocols to do the signaling and then carrying EAP there, then you do something slightly different, which of course it's also requirement that implementations to be able to do this or detect this kind of situation. But of course, we can't really always guarantee that there's never a case where no identifiers are asked for. So one has to build for that situation that you as phone or some kind of other client will actually get a request for identity. What do you do then? Well, 3GPP had developed a table what to do in these different cases there, and we basically follow that same here just to make sure that specs are aligned. This applies only to 5G case here, and I don't represent the whole table here. That we point us just give you an example. So in 5G, because basically all the identifiers that you pass around publicly are privacy-friendly identifiers. Now, if on the EAP level somebody asks you for the permanent identifier, then that's a warning sign. You should probably not agree to that. So that's why the spec says should respond with an error code in that case. Key generation, I mentioned that we use one of these two special identifiers in key derivation. So there's some language about that, like under what condition you do that, and then this is what you do, and these are the bits. And regarding the bits, there's a format question. It's not just a conceptual thing, but also a question of exactly how to represent things. There's a reference here to 3GPP specifications where they represent their identifiers in an NAI format. So their identifiers can be regular NAIs, but they can also be IMSI numbers. And there's two different identifiers as mentioned earlier. So one is this permanent one that is in the clear. Here's the example on the upper, or the upper example is like that. It's kind of easily readable. And then there's an encrypted identifier where the network part is like you specify what operator you're going to, but then you hide the subscriber identity part with public key encryption that's been specified in 3GPP, but it still maps to a NAI. And so we don't specify any of that. We just point to that and provide some examples. So that's identifiers. And then we have another thing that we wanted to make sure that the 3GPP specifications for 5G and the RFCs agree, because the previous RFC declared that in these and these situations you use like these strings to determine, like this is for wireless LANs, this is the string that you should use, and so on. Now here with 5G we're introducing a new string. The actual strings are in the 3GPP spec, but it's a different document and different version than the one pointed to by the original RFC. So we're pointing to both. and then the clients are required to, or actually in this case, the server is required to figure out what is being done and which identity or which network name to use. We export some parameters for session IDs, for fast rerouting for the regular case, and some peer IDs and server IDs. I should note that we're actually in sort of the common case here. ID and server ID actually turns out to be the empty string, because they're like, well, unless the IDs have been passed inside the EAP protocol, which in this case doesn't, or at least for 5G doesn't usually happen, then you don't have that unless you take the ID that was passed in the lower layer. And we chose to use the empty string. Not quite sure if this is a problem or not. I think it's not a problem. If people have comments on that, that would be useful. My understanding also is that while there is an RFC that requires us to export these parameters from EAP methods, there isn't a lot of implementations or even any implementations that would actually use this information. I don't know if people who have EAP experience care to comment if they've seen this information. But depending on the answers, this either matters a lot or doesn't matter a lot. Moving on.
You might check if it's relevant to you. I think the AbFab use, did you look into, like, there was this AbFab effort that used EAP within GS's API or something of that nature. And they may have used those quantities. I'm not sure, and I'm not sure if that's even relevant to your use case. So
we looked at some common open source implementations and didn't find any code for this, but
fair enough. Other than that, the only uses of that type of information I know is for like accounting purposes, which you probably have dealt with in another way.
And then the previous RFCs, and this has nothing to do with 5G. This is like a totally general change. The previous RFCs defined this pseudonym approach and fast re-authentication identity approach. And they sort of provided special usernames that can be used in these processes. And the assumption was that this be like totally random, and you cannot figure out what the user is from those. But we didn't actually say that in the specs. So now we're trying to say that you have to generate them in a fashion that doesn't reveal information about the subscriber or the user. And so, for instance, a counter would be a bad idea. A random number would be a relatively good idea. Username dash counter would be a terrible idea, and so on. We wrote an entirely new section on privacy considerations, just going through the basic implications of different identifier types. We set some limits on what to do in 5G. So if in 5G you are sort of protected against privacy violations, so looking at the identifiers, and then you suddenly use pseudonyms and use the same pseudonym multiple times, then you've disclosed that you're the same entity in these two instances, and that's bad. So the purpose of the 5G enhancements would be lost if you did that. So we are prohibiting that. We discussed the implications of different protection profiles. So 3GPP, when they did this encryption of identifiers, they have multiple different profiles, including the null profile, which surprisingly doesn't provide much privacy. We discussed that. And we discussed that the domain or operator is typically visible in these identifiers, even if the subscriber identifier is visible, is hidden. We also added a section on pervasive surveillance considerations, discusses in particular the attacks that were claimed to have happened a couple of years ago, 2015. The SIM heist, look up the reference from the draft. And obviously all protocols are vulnerable to compromise of the primary key material. We discussed some specific means to make sure that doesn't happen when you manufacture these cards. We also suggest that some form of perfect forward secrecy protection may be useful. We're not requiring that or pointing to, like, must do this spec, even if we have a spec that I'll talk about in a moment. But so we're just providing some advice here. We did add a fairly extensive section on discovered vulnerabilities, and this is what I was referring to when we were talking about John's draft, and how much to talk about general AKA issues, how much to talk about AKA prime issues. And I didn't have a really good we were unable to find a really good reference for, here are all the attacks, sort of fair and balanced manner reported on AKA. So we tried to write our own. But we do try to point out which things actually apply to AKA or EAP AKA and which do not. So basically, there's no there's no attacks on the fundamental properties of authentication under the original assumptions, but you have tons of different attacks. So obviously, if you leak the primary key material, you're gonna have some breakage. So that was what we talked about previously in the SIM heist case. You can also have the protocol participants misbehave. So in AAA systems, network access, you typically give some keys to the local network giving you access, and then like your access point or your 5G network or whatever could potentially claim to be the user in the sense of sending packets apparently from the user, and that's how it is. I mean, it's not that necessarily super concerning, but that's how things are in almost all access networks that I can think of, or in all authentication schemes that I can think of. And then there's some other stuff that is not really relevant for this, but I did point to, like, there's we did some of us RFC 3310, that is AKA inside HTTP, and it turned out to go really badly, and we didn't use the crypto keys in the end result, which meant that this is vulnerable to the man-in-the-middle attacks, and fixed that in a later RFC 4169. So we're clear, except that that's now 10 years ago, and some people are still using the older one, including some SDOs referring to the older spec for some reason. Maybe that's a task for some of us to go and fix, but that's how it is. So that's basically the bigger issues in this draft, or issues or things that we had done in the previous round, and where we are. Would love to get feedback and discussion. There's some ongoing discussion also with some 3GPP people. I've been able to at least interact with some other implementers. We're implementing some of this. But there's also others that do this, and like going back and forth, like, okay, what do you put in the identifier fields has been useful. We're also trying to add a reference to this draft to 3GPP specs. We'll see if that happens, hopefully. They're having a meeting next week, I think. And we think we understand now the interactions between the 3GPP specs and this, and maybe it's worthwhile to note that, like, why do we have to do anything to begin with? Like, if they just use your RFC, like, what's the problem? And that would not have been a problem if they just used the RFC, but they actually wanted to use the RFC, but do these and these changes and behave in this slightly different manner. So that's why we have to try and sync up, because if we don't sync up, then the result is that the RFC will say something, and possibly some implementations will follow the RFC and not do the 5G thing, for instance. We talked about working group last call. I think if we did one now, like after the meeting, that would align nicely with some other things. So
So are you, and right now the draft is up to date as with all the kind of discussions and things that you've had in 3GPP and elsewhere?
Yep.
Okay. Yeah. How many people have read this 5448 bis? Or any version, or later the better, but okay. Would some of you be able to, if we do a working group last call, can you give a review of the latest changes? Okay.
thank you,
Awesome.
Russ.
So yeah, I think we can bring this to a working group last call.
Okay.
Are we on the next that button?
Change the presentation so it will refresh. Okay, just to be sure.
And, you know, now we're in a different place. Up here. This one?
Yeah.
Yeah, that's. Clicks. We should be good to go.
Okay, so this is the other draft. This is an extension to the previous work, or any EAP aka prime protocol could be extended in this fashion. It's not a working group document yet, but we do have a work item in the working group charter for this. And we've discussed about this extensively last time also. I have taken into account reviews or the discussion that we had last time, and for instance, Mohit's review. And this version is more detailed. We also renamed the attributes and made the protocol use the ECDHE terminology and RFC 8031 terminology. And we clarified the use of the negotiation process. We only send one key if there's like negotiate groups or algorithms and so on. So we never send like multiple keys. We always send exactly one key, the one that we're trying to do. And we clarified the resulting security properties, which was an interesting exercise, trying to understand exactly what does this mean. And then last time, what had been Hannes who brought up denial of service attacks, tried to clarify that as well. And so basically the protocol is that there's a pair and the server, and they pick some private information and generate some public keys based on that using elliptic curves. Send an EAP aka challenge request with like all the usual attributes, but also the attributes relating to the perfect forward secrecy calculation. And now my attribute names may not be actually updated on this slide entirely, but it should be updated in the draft. And then if the pair does not support this or doesn't know anything about this protocol, then it will just ignore this and continue as it does normally, if that's allowed by the parties. But if it does understand and want to do this protocol, then it also picks its private information, generates a public key, and does some calculations, and sends the public key to the other side, which also does some calculations based on the private information and the other side's public information. You calculate a shared secret, and then you feed that shared secret into the process that normally in EAP aka prime would result in the master keys. And then you use that, or would result in the keys that are output from EAP aka process or the EAP method. So it's pretty simple at that level. There are some tricky parts though. So one is backwards compatibility that I already talked about a little bit, how to avoid changes, or how to run in different kinds of environments where not everybody may be supporting this yet, and how to minimize changes all over. There's some negotiation issues with both, like how do you negotiate if you have support multiple algorithms or groups, and since there's already negotiation processes in the EAP aka prime, how do you fit together with that? and then there's DOS issues. So I'm going to go through these briefly. So the first design principle was that like we don't actually want to affect the SIM cards, because that would mean like we'd have to send SIM cards to everybody again. A couple of billion SIM cards that would cost at least a couple of billion in the stamps alone. So we tried to do this on the phone, and then on the network side, we tried to put it on the EAP server code, not the server that holds the permanent secrets. So this keeps the interface, the SIM card, and the authentication database unchanged, and no changes to minimal changes to infrastructure, and no changes to credentials. But of course, you have to have to update the phones, have to update the EAP server. The other one is that we wanted to make sure that we can do this in a backwards compatible fashion, even if like we have partial deployment, and like my server supports this already, but not every phone does it yet, and we can't exactly figure out what phone is on the other end at that point. So we want to avoid situation where we'd like have to wait until everybody's deployed, or cause some penalty in performance when expectations don't match. So we wanted to do this so that there's no extra round trips when we use this new feature. And if we fail to use the new feature, I have to go back to the old way of doing things. There's also no extra round trips in that case. In terms of we can run the both processes in parallel. We just do the old thing, and then on top of that we do the new thing in the same messages. And if that succeeds and both parties support it, then the output kits will take into account the new thing.
So in your use cases with 3GPP, would it be possible to, could you use a different EAP number?
Different method type.
Yeah, different method type.
One could, yes.
Because I haven't looked at it enough, but you could try an approach where were able to encrypt more of your messages using the Diffie-Hellman. It might always add an extra round trip.
Yeah, that is the cost.
Okay.
Yeah. And I'm not like, we'd have to do the math, like what's the benefit, but that is exactly the cost. That would add an EAP level negotiation if the other guy doesn't support this new type.
Right.
And that's because the way that the EAP was originally defined.
Okay.
So it's
and you don't have, because yeah. All right. I mean, that might be something to have a little bit of a discussion about, and see if I don't know what benefit you would necessarily get from encryption either, but I mean, you would get the benefit of the encryption, but how important that is in the scheme.
Yeah, but you don't get like the encryption that you would get. Like, it's actually I think it's not there's other ways of doing this, but I think the beneficial ways, like if you just do like an EAP level negotiation, I don't think you actually get any benefit from that. You just do the same thing, but if you reorganize the messages in some other fashion that you did, like a little bit like IETF2 or IETF1 does, that you first do this key material generation thing, and then on the next set of messages you do the rest, and then you can actually encrypt maybe more, and that might be a useful thing to do, but even that has the trade-off of an extra rounder.
Yeah.
So there's negotiation or new negotiation in this extension. So it's a simple extension, but you still have to build for the possibility there'll be more than one algorithm or more than one group in the future. So for that we have this AT KDF PFS that indicates the preferred algorithm is just the first one, and then the possible other algorithms. The server sends this. And if the preferred algorithm is acceptable, then the peer just executes this protocol and proceeds, and there's no RTT hit. But if you do want to do some of the other ones, not the preferred algorithm by the server, then the peer indicates that I want this other thing instead, and then the server responds, and then there's some special rules that you you carry all the relevant information still in all the messages, that you can't actually change anything without causing the max to fail, and you have to check for that. But that's always a round trip that is added if you don't go for the default. And only the key for you send the generated public key on the first message from the server, assuming that the guy will accept the preferred algorithm. And if he doesn't, then you have to send another one with the other key. But you never send more than one, exactly one, always. And then there's a question of how does this negotiation process fit with the previous negotiation that exists for the KDF negotiation in the original RFC. And they're actually very similar. They're exactly the same process, just that they're negotiating a different thing. And they're currently defined as separate. Like if you have to do the negotiation, then you do one, and then you do the other one after that. In theory, we could probably define this to happen also in parallel, but maybe that's not worth our time. Seems simpler this way. If people have opinions otherwise, then we can talk about that. Denial of service, and Hannes had this question last time, and Russ, I think you were also commenting on that about the order of computations, and that was actually partially in the draft already last IETF, but it wasn't entirely there, and now we have all of that there, and also talk about it in the security considerations. And here's the deal. So the first message in this whole protocol comes from the server. And it doesn't come unless you've already identified that this is the given subscriber, or we haven't authenticated the subscriber, but we've seen a valid username. And you can spoof this, but it requires the attackers at least use specific real identities. They can't just randomly generate numbers and try and use them. So that's first level of defense. And the second level of defense is that once you get the messages, then all the parties, at both on the peer and the server side, they will first do the old process. They will authenticate using the long-term shared secrets and make sure that succeeds. And if it doesn't succeed, then the person or the other party doesn't have the right key, and therefore this is an attack, and you bail out. You never do the expensive computation. It's only after that succeeds that you run the expensive computations. So the parties need to show possession of the key material before they do the heavy calculations. Russ?
Sorry, I just don't remember where the MAC check falls and where the key for the MAC comes from, but it seems that it's important to avoid the downgrade of algorithm attack, the MAC, right?
Yes.
So it would also, I think, affect this.
So the MAC, I think the MAC is done, like it's done as the previous or the original RFC does that. So you calculate that the MAC process is done. That is step one, and step two is generate the keys, and then the resulting higher quality key is then that is the output from the EAP process. So now your traffic protection can be protected with this higher quality keys, but your MAC will still run on the original process.
So what I think you said, and I'm just repeating it back to make sure I understood, is that the MAC is dependent on the base AKA authentication.
Yes.
Okay, thanks.
And so after all of this, like if you still have somebody who's trying to DOS you successfully, then you can take some operations actions like blocking that particular subscriber. If it seems to be sending millions of requests, for instance. I updated the security properties also. I'm trying to be accurate here. So basically, what does this give you? It gives you that, like if we have used the SIM card and now somebody at some point learns the key, then and that somebody has recorded all your previous conversations. Now you can't go back and look at those previous conversations and decrypt them because BFS was in effect in those things. And also, if the attacker still has the key but doesn't do active attacks, then future communications are also secure. And then if the attacker who has the long-term key is also an active attack, then nothing can be done. Like they can do anything. They can pretend to be any of the parties. They can also be a MITM if they need to. And they can determine the session keys, change the negotiations.
They know the secret.
Yeah. And yeah, so that's the end of my list of these tricky things here or the updates that we've done. And like with the previous one, love to get some feedback or even more feedback than we've gotten so far. And I think this, at least from our side, would be interested to see this as a working group document. Again, there's this window of thing for some amount of time in the future. It's not the next week thing, but for the next half a year or something like that. If we have a solution in this space, we might actually be able to stick this into the next release and actually have an effect on people's security in this sense, protection from the organizations that try and spy on things. And there's some interest from our side, certainly, and then another manufacturer working on the chipsets may be also interested on this. So we might actually get this actually deployed if we do it. So I would love to move forward on this. So that's the end of my part.
How many folks have read at least one version of the AKA PFS? Not so many, but a couple. That's good. And is anybody? Well, let's take a kind of an informal hum, and then we'll take it to the list. But does I'll ask how many people support adoption and if anybody's against adoption of this. So hum if you support adoption. Okay, hum if you object to the adoption of this. Object to the adoption of this document. The abduction of this document? All right, well, we'll take it to the list, but thanks, Yari.
Thank you.
All right, next up, Eep Noob.
Okay, so I wanted to tell about this EAP method called EAP Noob, a nimble out-of-band authentication for EAP. And what it does is it's a bootstrapping method for smart appliances. Now, there are many of those, but this is an EAP method. And we have worked on this for quite a while, a couple of years, and we are at the version 4 of the draft. The specification starts to be pretty complete, but there's still some things to do and to review and to document about the design process. So what problem does EAP noob solve? Well, it is an EAP method that is intended for deploying IoT devices or appliances out of the box when they have no identifiers, no credentials, and when you don't have professional system administrators doing the deployment, but just average users. And what method of authentication do we use? Well, user-assisted out-of-band authentication. And for example, in our implementations, this has been scanning a dynamic QR code or dynamic NFC tag. And in addition to just authenticating the device once, this method also registers new devices to the authentication server. So you don't want to let the user every time you want to connect to the, let's say, Wi-Fi network to redo this process, but once, and then we create a permanent association for that device, and that association then authorizes the device in the future for network connectivity, and it gives that device an owner and assigns a network to it, so it's a two-way authentication process and trust relation that is created. That is different from the current EAP methods, which require pre-registration of the peer devices. So here is the protocol architecture, and we have, as usual in this case, a Wi-Fi network and with an access point, and then we have this IoT appliance that would like to join the network, and we have some AAA server like Radius server locally on the network. In our use cases, we have kind of thought that the actual server that does the authentication is a remote AAA server, maybe in the cloud, maybe on site, but it's a separate AAA server that implements this EAP noob out-of-band message processing and the user interface for that. And okay, so what's the point of this? Well, we use the EAP tunnel for in-band communication with the authentication server. So that way, we are actually the appliance is able to talk with the authentication server before it is registered on the network or registered at the authentication server, and before it has full internet connectivity. So that's the main trick that we are playing here. And how do we achieve this? Well, the device initially uses this network access identifier noob at eapnoob.net because it doesn't yet know what identifier it will have. And then we route that realm to this special AAA server that supports our protocol. And then the out-of-band communication happens there. That's why we need this kind of special server, because it needs to have a UI or API for delivery of these out-of-band messages. So here in the picture, there's a single out-of-band message from this appliance through the user to this UI, if it's manual configuration, or API if the user is using, let's say, a smartphone with app to assist them. And so there's just single message in one single direction. That has been our design goal. And that message could be also in the server to peer direction. So we wanted to make the protocol as generic as possible and to allow both directions for this out-of-band message. Actually, the server to peer direction is easier to get security. And here is then a quick outline of the security protocol. I think it's pretty obvious to now that if we see that so first in band in the EAP channel, there is this ECDH key exchange, and that is unauthenticated at this point. And then we have the out-of-band communication, which authenticates the key exchange. Now we have two ways of authenticating that. The first one is a hash, including this out-of-band message, which is just a hash of this ECDH parameters, and prevents man-in-the-middle attacks or impersonation attacks on that. The receiver of that message can verify that part of the message. And then after that, there's key confirmation. And for that, we have another part in this out-of-band message, which is a secret nonce. And so these are the hoob and noob. That secret nonce will be used in the key confirmation step for computing max, and that gives a second method of authentication. So these are kind of redundant methods of authentication, but I'll explain soon why we have both. And here it's just the names of the messages in the spec. So there is the initial exchange, there is the out-of-band step, and then the completion exchange. Well, this is the protocol that takes place when you register the device, and then in the future, there will be the persistent association that is created here in the key after the key confirmation, and then reconnect to the network. Rekeying happens with this reconnect exchange, which may use nonces or for forward secrecy, also ECDH keys. And that means the user-assisted step will not be repeated as long as this device stays registered, and it will stay until the user resets the association either at the server or the device end, or actually has to do it at both ends. Okay, so where does what kind of security do we get here? Where does the security come from? Well, we had this one. We wanted to have like minimal assumptions in the protocol on the out-of-band message. So it's just one message in either direction, from server to peer or peer to server. And we assume that the out-of-band channel will provide either integrity or secrecy, but we don't require both. But of course, I would say it's like better to have both. But if you think of, let's say, scanning a QR code, someone could be spying on that QR code, so it might not be so securely secret. And then it's only the integrity that remains to protect the security. So it's kind of for fail safety, we want to have these two assumptions, secrecy and integrity of the out-of-band channel. There's some tricky case where when there is no secrecy for that message, just one message is almost enough, but not quite enough. So the user needs to, in some cases, detect the failure of one end to associate, and then go and reset the other end. So that's a little bit more than just one message. Well, another concern that we have had in the last year, we've spent a lot of time on modeling this protocol and verifying its properties. And the main concern we had was this denial of service attacks by someone, a man-in-the-middle attacker on the in-band channel, like on the wireless network, who could maybe they could cause persistent failure of the protocol. And I hope it's not. Oh, I feel so powerless. Okay, so the man-in-the-middle attacker, especially, it could tamper messages, or it could drop messages, or maybe it could spoof error messages and use that for causing denial of service. And we can't avoid that, but we want to avoid persistent denial of service if the attacker then goes away. So here is a use case to get an idea what is this useful for. So secure bootstrapping of cloud-managed displays. And this was our initial use case that motivated the work. So here is a comic strip. There is Alice, who is attaching displays to the wall, powers up one of those new displays. The display doesn't know where it is. It scans the wireless networks, looks for support for EAP noob. When it finds that kind of network, it connects to that network. There happens to be just one in this case, and the initial exchange for the protocol happens in the background. It gets a QR code. This is the out-of-band message now. The QR code shown to Alice, and Alice scans the QR code with a smartphone, which may or may not have an app. So it just needs to be capable of scanning QR codes, and a web browser will be then open. But it's kind of, there's all kinds of tricks against the user phishing type attacks. So would be a little bit better if there is an app, but it's not required. And then the user has to either be already logged in on the cloud server or will enter the login credentials, and that magically attaches the device to the cloud service and then enables network access, because the cloud server is now the remote AAA server. And now the display starts in our implementation, then it also gets this application layer configuration and starts displaying some content. So to recap this use case, there's a new display device with no owner, no domain, no credentials for either cloud or Wi-Fi. And in one step of scanning the QR code, we managed to register the display device to the cloud, get Wi-Fi access, link the device to a user account on that cloud server, and we also managed to export the URL and key for application layer bootstrapping of that, whatever the device is supposed to do, like display some web content. And the display device here was output the OOB message as a URL encoded into a QR code, but the display device has no input. So that has been kind of our idea that, well, you have to be able to reset it in some cases if it doesn't start, but apart from reset button, it doesn't need to have any input, just the display obviously has output. And the user has the smartphone, and then what we need to have in the background is that the remote AAA server is configured with the local AAA server trusts it for authentication, this EAP-noob.net NAIs, and also in this case the remote AAA server is integrated with the application level display management service. And here this still shows the same comic with the protocol steps, like the initial exchange with ECDH happens in the background, then the out-of-band message is shown, the user scans it, it's delivered as through the URL to the cloud server. If it's a web browser, the user here needs to check that it's the correct cloud server that she has an account to, and then log in. And then there is the final key confirmation that happens again in the in-band channel without the user noticing anything. So now I have a long list of some kind of design details and issues here, and I've selected some that might be of interest. So maybe the obvious thing is to say, what is in the out-of-band message? Well, there is an identifier for the peer. That's a server allocated identifier that just helps the server to know which message is belongs to which peer. And then there is the two fields, noob and hoob, and the noob is the secret nonce and hoob is the hash of the ECDH parameters. All this can be encoded, for example, and then in the spec we show an example how to encode it as a URL. And that's an important thing to know, that is a dynamic URL, so it will change after every initial exchange, it will change. So let's say if it's a display you configure, it might change every minute or so. So it can't be a printed QR code. It's a dynamic QR code or a dynamic NFC tag. And in this, noob is the part that requires confidentiality, and hoob is the part that needs integrity. And one of those is enough to get security here. Well, when we create this persistent user association, so we don't want to repeat this authentication, and this is kind of one place where the method differs from typical EAP methods, that you have some method of authentication and you keep repeating that, but we can't do that. We can't trouble the user every time the device gets disconnected from the wireless network. So we must create a persistent association and then basically at all cost avoid rerunning that out-of-band step and authenticate with this association that was created. We allocate we need to allocate some identifier to the peer that is not necessarily visible to the user at all, but within the protocol, the peer must now, for this persistent association, it must be given an identifier. And when we assign identifiers, we need to think about things like identifier squatting. So we can't believe any identifier that the peer gives us, or we shouldn't choose identifiers that the attacker can somehow steal from us and use and prevent the peer from associating. And the way this has been solved here is that the peer starts initially, the initial exchange as anonymous, and then the server allocates an identifier to that peer and allocates one in every initial exchange. And then eventually one of those initial exchanges succeeds, and usually the first one, obviously, but if there's something goes wrong, it may have to repeat it several times, and then that identifier that leads to the successful OOB step and completion then remains the peer's identifier for that server. The device can additionally send in this protocol, as there's this peer info field, it can send some other information about its capabilities, like its brand and type and so on. But that information is something that is authenticated in the sense that it is sent by that specific device, but it's not authenticated in the sense that the user has to verify that the device itself is not lying. Like if you don't trust all your IoT devices not to lie. So if the device says, I don't have a camera, it might still have a camera unless you really look at it, whether it has a camera. And maybe some cryptographic assertions could help in this kind of case to check what capabilities it has. The association, in the use case, we used it for bootstrapping application security. So the method can export keys to the application layer, and we also have used it to convey initial application layer configuration to the peer. Although I now realized during this meeting that we actually need to clarify how to do that, and then maybe make it clearer in the spec. And if you compare this with, to me, it's essential that we bootstrap the application security with the same step, because that was our initial worry, that when we configure these devices like displays, you often have to first enter wireless credentials tediously to an IoT device, and then configure some cloud credentials for connecting it to the cloud. So you have network access and then the cloud connection. And if we skip one step here, then we are kind of only halfway through. Roaming support is something that was in a previous IETF meeting that I attended, suggested by the EduRoam people, and we certainly can do that so that the device is configured in your home network. And we have added this option for the server to send a list of SSIDs, so that in addition, or instead of the SSID where you currently configure the device, you know that your persistent association will be valid also on this other SSID. So for example, if I configure the device on my university network, then it would, the association would also be valid for EduRoam, and the server can allocate a realm for this purpose for the device. The wireless network selection here has kind of troubled us a lot, because we thought about the displays that should not have any user interface at all. So we didn't want to select. So if you have a one button on the display that you can use for selecting the SSID to which you connect it, that solves the problem. And most implementations probably would do this, but it is actually possible also for the peer device to scan the wireless networks for one that implements EAP-NOOB, and where the server supports it, and then perform the initial exchange, and then just whichever server first completes the exchange with that peer then wins ownership of that device, and then the peer connects to to that wireless network. The one thing that we have had to give a lot of thought to is this possibility of multiple out-of-band messages being in flight at the same time, and there are several cases where this may happen. So there could be just that if it's a display and the code changes every minute, the user may just scan two different codes, or if it's a printer that prints those codes, that's easy to think, like those papers just lie around, and there's lots of them around, and one of them eventually gets delivered to the server. And another case where you have multiple messages in flight is that we support both directions, peer to server and server to peer, for the out-of-band message, and never thought that anyone would want to support both directions. But then now, when you think about it, someone might be crazy enough to implement a device that allows both directions, that the protocol allows both directions for the. Normally, you would think like output device outputs a code, and input device inputs a code. But sometimes the device might be able to do both, and the protocol supports that case as well. And then, as I mentioned in the previous slide, there could be multiple users delivering out-of-band messages to different servers, and which are behind different wireless networks, and they compete for the device. And we've worked out these different cases of multiple messages in flight and verified this to check that there is no deadlocks caused by these. Another kind of, for what has been quite interesting for me as a security researcher to think about is this CryptoSuite upgrade issue. So that is of course an event that happens very rarely, but since we decided that we don't want to bother the user to redo the out-of-band step again in any case where we can avoid it, we wouldn't want to bother the user even when the CryptoSuite needs to be updated. And so the normal solution when you update, let's say, the crypto algorithm for signature keys for someone's credentials, you also issue a new certificate, and that's a kind of administrative process, and a human is involved in that, or some another level of credentials for deploying it. But we don't want to do that. So that's why in the Reconnect exchange may negotiate a new CryptoSuite and update the persistent association keys. But this leads us to the really interesting stuff, where the CryptoSuite update might fail, but it might fail so that it fails for one end and succeeds for the other end. So the issue here is if you're doing a CryptoSuite upgrade in the Reconnect exchange, and then the last message, which will be the final EAP response, that is dropped, the peer will move to the new CryptoSuite because it thinks all is okay, but the server will never receive that final message, and it will keep the old CryptoSuite. And that is kind of an unavoidable problem in a distributed system, that you can never reach this consensus about, are we in the new CryptoSuite or not, or is not guaranteed? We can't design a protocol that is guaranteed to reach such consensus if the message is maybe lost. But the way we solve this is kind of make the peer responsible for the upgrade, and the server just moves to the new one whenever if it gets the final message. If it doesn't get the final message, it stays in the old one, and the peer is willing to roll back to the old one until it receives a confirmation that the server also has done the upgrade for that association. And when does it get that confirmation? Well, next time it does rekeying. So if the synchronization failure happens, obviously the peer cannot connect to this network, and then it tries immediately to reconnect, and that's when either the peer will discover that the server is in the previous CryptoSuite, or it is in the new one, and then it only keeps that one. And all the attacker can do is it can again drop the final message, and then but if the attacker eventually goes away, then the upgrade will succeed. But this was kind of fun thing to model how this process works. One note about isolating the peer devices. So if you think of devices that connect to this wireless network, and you let users configure new devices and connect them to the network, well, they might connect all kinds of devices to it, and especially like any out-of-the-box device that supports EAP Noob and buy it from the shop and just attach it to your local network. Also, we in our use cases we delegate the control over this network access to some cloud server, which may be provided by a third party. So if it's not your own remote authentication server, but some external service, then you're kind of trusting access to your wireless network to them. And obviously corrupt devices, IoT devices, might leak the network credentials and let anyone on your wireless network. So we think that it's quite important to isolate these devices to a virtual LAN and that so that they don't get in touch with your regular hosts on the network. Preferably isolate them from each other as well. But the current access points and radio servers don't really support such features as far as I know, but we managed to implement it on open source radios and open WRT access points. Well, this is not something we can solve in our protocol, and it applies to all kinds of IoT stuff. But I just thought it's something to keep in mind because it's probably like one of the big security weaknesses of doing such device associations. For software requirements, I just want to point out that the implementation is now on this remote AAA server, and on the IoT device, we have implemented those in Linux host APD and WPA supplicant. But access points don't need any changes, and the local AAA server only needs some minor configuration changes that is routing these specific requests to the remote server. Maybe I'll skip the to-do list. It's just some what we need to do next. And then summary of kind of, well, what was the solution? What was it that I talked about? Well, why would we use EAP for bootstrapping devices? Well, the trick here is that EAP allows us to do the in-band communication with an authentication server in the network, internet or on your backend network before you have network connectivity. And thanks to that, the out-of-band communication can be one short message. And if you don't use the EAP tunnel, you usually have to communicate much more information. And then the out-of-band message in our protocol is designed so that it should get either the out-of-band channel should provide either secrecy or integrity, but if one fails, we are still okay. And then kind of you can ask, like, we get this magic attachment to the network with just scanning one QR code, but what's the cost here? And of course, one thing is that we need EAP and AAA, and that means WPA enterprise, so not passphrase networks. And then the main thing is that the network admin has to choose one such authentication server. So the network administrator makes this choice for you. And in this one network, you can attach devices to one authentication server. There's some comparison to other methods. I won't go through these, but I'll use this slide to answer questions if someone points out these questions about comparison. And there's a link to the draft. And then finally, why am I presenting it at the EMU working group? Well, we don't have a working group that would be suitable for this draft at the moment, and I would hope that if the EMU is rechartered, then maybe consider including EAP Noob in that charter. And also, it would be nice if we can use the working group kit and for editing the draft and the issue tracker, so that it would be a little bit more public and we could get external contributions to it. Okay, that's all. Questions?
Hi, great presentation. I could almost borrow all of your slides except for a handful for the next one, but I won't. that I think actually we have there's a side meeting I told you about tomorrow, 6 p.m. It's on the side meetings wiki, and I want to look to address, like, there's a series of IoT onboarding work that's going on across the organization, and so I want us to get our hands around all of it. But I would definitely support, if it's possible, to use the EMU working group wiki to track issues here with this. And I look forward to working with you to try and find the common architectural components on these.
Okay.
Yeah. I don't know if we can use the EMU working group wiki at this point because they're not working group items. But there should be some way to do that somewhere.
Eric Nordmark, yeah, this is very interesting. I think I have other use cases when the output device is just an LED that can blink, but you can have your phone receive that stuff somehow. One question I had was, so can you do mutual authentication? Can you authenticate the AAA server with this as well? As long as the device has some credentials, it knows it's going to talk to whatever EAP-noob, whatever, right? If it is that something that already exists in the software you have?
Sorry,
Can the device authenticate the AAA server?
Yes, so it is mutual authentication. The device is authenticated as a physical device. It's the identity of the device is defined by which device, where the user reads or writes the out-of-band message. So it's a physical device that the user accesses.
Sure, that part, but the AAA server as well. Can authenticate
the
that one.
AAA server. So here the user is assumed to have some way of secure channel to the AAA server. It could be, of course, physical if it's a home network and some device, hub at home. But in our implementations, it is the remote AAA server in the cloud where the user has a user account or user uses the organizational account
Sure,
for
that's
logging into that online server, and then the device is not only associated with that specific AAA server, but with the user's username. And
that's the exchange between my cell phone or whatever I use to scan the QR code. Understand that part? I'm talking about the EAP exchange, whether that offers mutual authentication in this case.
Yeah, so this fact that the user has this secure channel to the AAA server, it does authenticate the AAA server to the device. So basically the device in our use cases takes that.
Well, to follow this is Dave Robin, to follow up on that, because I'm with him. You mentioned on one of your slides that if you don't know which AAA server to talk to, you just talk to them all.
Yeah,
now that is concerned. Now, what QR code do you present at that point? Because you have three, you've got two evil AAAs that you're talking to and the real AAA. And which one do you present? Now, I understand fully that the user is going to go to, my company that I trust and paste in that QR code. And that's great because then the peer knows which one of those three it was but still, how does he present
the display? Well, the display shows these three codes. And if the user somehow is tricked to choosing the wrong one, then it doesn't really do anything. There's no because it's the correct server that you're delivering it to. That's the important thing. But I mean, this will have the QR code has well, in our case, we write the text there, the base URL under the QR code.
Right, but in your
so let's say the display, our display would rotate 2 or 3 QR codes with the base URL under it, and you choose the one you recognize.
Okay, I think we should probably move on to the next. Is it a quick question?
I have a quick question.
Yeah.
So I love this idea very much and very effortless process for users. And so is there any requirements for like IoT vendors to develop in the device itself, like just display the QR code? Or
so the implementation, it would be like we have implemented the Linux PA supplicant, so it's the EAP supplicant side module. But actually, you're pointing out to the tricky part of the implementation, which is integrating the EAP layer with the user interface.
Yeah.
Thank you.
But you haven't been abducted. Hi, Elliot here. Last meeting, Owen presented on something that we've been tossing around, which is to take the Brewski work that's been done, the bootstrapping key infrastructure work, and apply it into EAP. So the problem statement, it was pointed out that maybe we didn't do as good a job on a problem statement as we should have in the previous presentation. So these are basically a couple of reasons why we went there. And I'll set this through in just a handful of slides. This is a very short presentation. The key issue is that we need a trusted introduction between a device and a local deployment. Absent that trusted introduction, device is going to join the wrong network. They may do so either out of incompetence or malice, depending. And I think everybody in this room understands that problem. Brewski provides for a trusted introduction, and it's a certificate-based method at this point, and it also relies on a third party, which is to say the manufacturer. You go out to the internet, manufacturer says, device has got to, I'll explain the flow in a minute actually, so I'll go through it. Once you have a trust anchor in Brewski, you go and you do an EST transaction, and you get yourself a local deployment cert, and both of these mechanisms assume some amount of network connectivity. Really, it's internet really that's not only network connectivity of the device, but it's also internet connectivity, as it turns out, in terms of Brewski. And you just don't have the network connectivity in 802.11. Obviously, you have a chicken and egg problem there. So, of course, we looked at EAP for the exact same reasons that the EAP noob folks looked at EAP. We thought it was pretty cool for the exact same reasons. And in fact, we thought TEAP was even cooler because it covers a fair amount of this ground already. And it just needs a little bit of tweaking. TEAP tweaking? So here's an eye chart for you. This is actually on the materials page, so you can just look at this. This is the basic ANIMA flow, where you establish what we call provisional trust. It's directly analogous to what EAP noob does in many respects. What you do is you go through a transaction in which you go where essentially the local deployment, which is the switch and the registrar, really the registrar goes and asks the manufacturer, is this one of your devices? The manufacturer can say, yeah, it is, or no, it's not, and essentially sign a voucher request, which then gets returned as a voucher, which the pledge can then use to say, yes, okay, I should join this network, and here are the credentials for that network, and then you go through an EST transaction. Again, you have this problem, which all that was IP-based, work done in the ANIMA group, and so we have a little problem there if you don't have IP connectivity yet. So what's the idea? Shove the whole thing into an EAP flow. I am not going to go through the whole EAP flow today. You can read the draft. But the basic idea is that we're leveraging EAP TEAP. We've created just a handful of new TLVs that one would use to do this. The differences between this version and last version is that we've created it even a handful less than we thought we needed in this version, and so we're trimming down. And so the other difference is that we actually documented out all the TLVs that we think we need, and I added considerations to match. The flows themselves have been updated because in the process of defining the TLVs, that's how we found, oh, you can piggyback messages and EAP isn't that so lovely, so let's condense here and here and here. We have. And so obviously, if you look at the security considerations section, it says TBD, which means we're nowhere near ready for adoption, working group adoption. We're just not there yet. And we think there are some in the process of doing this draft, and also the process of looking at EAP noob, and in the process of looking at DPP as well, actually, we think we've come across what we see as some architectural questions. And so one of those is that there seems to be, we see challenges around the sorts of deployments that need to be accommodated in terms of credentials that they're comfortable using versus the capabilities of the device in terms of the credentials that they can support. And so in the process of going through all of this, I've attempted to identify a few architectural building blocks. And I'm only going to tease you by saying that I've done that, but I'm going to present it in Ops Area Working Group. And then I want to talk about it at a side meeting directly afterwards tomorrow night at 6 o'clock. It's on the side meetings wiki. And so at this point in time, we're not asking for working group adoption. For one thing, I would like to look across the 5 or 6 different working groups at this organization and then 5 or 6 organizations that are looking at this entire problem. We're seeing fragmentation because of this, and to just take a step back for a moment, pause, take a breath, and say, what are the common architectural components? What can we do to maybe reuse some of those architectural components as we evolve all these mechanisms into the future? So this is more of an advertisement than anything else. Please come to the Ops Area Working Group tomorrow. Let's have a bit of a discussion there about this. I've got about a half hour to talk about all of this. I'll try and speed talk a little bit even in that so that we have more time for discussion and less time for Elliot blabbing on. And then please come to the side meeting tomorrow evening. It's in apartment 3 on the 9th floor. We only have a 12-person room, but that's okay. I figure if 100 people show up, we'll just switch rooms with someone or have the meeting in the hallway like we usually do. That's it. Questions, comments?
Dan, you may speak.
Close the line again. Dan Hargens. Thanks, Elliot. I have a few questions after reading this. So does the device need to respond to the EAP identity request with any sort of adornment to route it back to the right TEAP server, or is it just assumed that there's always one TEAP server for every authenticator?
We haven't even answered. It's an issue that you've just raised, and the draft hasn't even gotten that far.
Okay.
But it's a fair question, and I see no reason to adopt the exact same method, for instance, that the noob people used.
Okay.
In fact, I like that idea. Can I steal it?
You set up this provisional TLS connection, and that's going to be completely unauthenticated. So it doesn't provide any security over just sending the Brewski voucher request and getting a voucher response in the clear.
Right.
So why don't you just make, instead of hacking TEAP, just make Brewski and send a voucher request and get a voucher response or an error back? Oh, so essentially, Brewski does the exact same thing. And the way that the provisional thing works is that what you have to do is, by the end of the transaction, you have to have been able to authenticate the beginning. You have to have been able to authenticate the credentials that were used in the beginning. If at the end of the Brewski transaction you have not received the appropriate trust anchor, then you throw away the whole transaction. Is the way that it works. But if you're going to be doing Brewski after you get your voucher back anyway, then what is
No, that's
what's
part
the point
of it.
of verifying your previous provisional?
So all right, I will go through the flow if we have a few moments. Okay. So the basic idea, let's see here. So the basic idea here is you start with, is there a pointer on this guy?
There is, I think, the very top button.
So there is. Okay. So essentially, here's where you enter a provisional trust state, right?
Yes.
Okay. And at this point, you have no reason to trust, which is why you're in that provisional trust phase. In fact, that's a really good signal that says, ooh, I need more trust. Let me go do some Brewski or something like that. So you end up doing a request voucher. I think we might even be able to nuke that guy, but I'm not sure. You end up doing this request voucher, then you get a response. At this point in time, you should be able to have validated
the server hello if you're the client, right? At which point you're no longer in provisional trust mode. So I won't claim to be the perfect expert on this trust model. That's the work of Max Pritick and Kent and Michael Richardson. But I'm essentially borrowing that model wholesale.
So what would happen if you just did Brewski request voucher, and then Brewski voucher? The bottom.
If we just did this part here?
No, just the bottom two.
Right.
3 and 4. 3 and 4.
These guys, 3 and 4. So we're relying, we're I think relying on the confidentiality properties here, at least in a provisional way until we get back the cert. And if we don't have confidentiality, we're going to need some other mechanism for that.
Okay, but you're still susceptible to like a man-in-the-middle attack, so your confidentiality is
until you don't have the proof of that you haven't been man in the middle until you get the trust anchor. Once you get the trust anchor, then you know you haven't been man in the middle.
Okay, I've got a couple more questions, but you want to push yourself on the stack.
Yeah, I just want to. Is it Brian Wise? Just a clarification. The provisional authentication part is actually only on the client side. So the server side is actually assuming Brewski assumes the server side can actually has the trust anchor he needs to validate the device. So it's just the device side.
But not here.
No, I wouldn't even go that far, Brian.
Well, that's the Brewski that's the Brewski model that's defined by Animus.
I'll trust the IDEF ID, and the other guy says, "Well, just trust whatever certificate." Okay, so I didn't understand some of these flow diagrams because EAP's a lockstep protocol, and you have sometimes people the server sending two messages back, like a CSR attributes, and I mean.
So the idea is that those will be in the same EAP message.
As just additional TLVs?
Yes, just additional TLVs.
And then, so my final request then is that you're overloading like a PKCS10 TLV and the CSR attributes TLV by sending a 0 length, I guess. So instead of that, could you just use the request action TLV and use the action field of it to say, like begin Brewski, instead of sending an empty PKCS10, which is kind of weird for the server to send a PKCS10 in the first place. And it's with 0 length, it's sort of like the semantics of that are what?
Sure, we could absolutely adjust that. Let's talk, because there's a lot of room. This draft is drafty as drafty can be, even in its second iteration. So we have, we want to tighten up some of those flows. Okay.
So Max Pala, Campbell Labs. I was actually thinking about the old trust models, etc. Without trust anchors, it will not work, because if you seek secrecy or of the parameters that you passed in the past, if you have a man in the middle and you detect it afterward, the secret is the confidentiality is already compromised. So
I'm going to refer you right back into the Anima draft, which goes into great detail about all of the security considerations of the mechanism.
Okay, but that's it.
Mohit, I think we are almost out of time, so I'm asking this question to the chair as an author. It should be fine to use Git even for individual drafts. We don't have any strict policy on that.
I mean, I don't know. We should discuss. I mean, I would prefer to keep our Git account for our, for official working group items, and then, I mean, it's easy to create a Git account, a GitHub account, right? And
so I plan to take this up in a separate context. So I think it's important that the new draft have a place to do that, and also this one as well. If it's not with you guys, then we'll sort that with the, I'll talk to some of the IESG members to see if we can find the right place to allow for that.
I'm willing to discuss that too. It's just, I'm not.
This is a solvable problem. I wouldn't worry. I'm quite certain we can solve this one. All right, that's it for now. So don't look for adoption anytime yet. But we want to have this architectural discussion. Please join in.
Sorry, just one more question about the adoption. We saw the several proposals, right, going the same direction. We had some messages from the last meeting.
Help us ship the existing items. Review EAP TLS, review EAP AKA. Once they are shipped, we will have space for recharging.
Okay.
Ooh, big threat.
So we'll have to wait until those items are.
Oh, we can be very fast if you review them tomorrow. You know, we can move them faster.
All right, we are done. All right. Thanks. All right. Yeah, I mean, we can talk whether it's appropriate or not. It's just as we get more and more things, it'll be confusing as